Hi everyone, welcome to Math Learning Hub, a hub for everybody who loves math. So today you'll be learning how to find the number of factors of a number n, specifically the number of positive integral factors. So what this essentially means is basically the number of factors that are integers and are also positive, right? So we're going to jump in and follow these 3 steps with our first example, finding a number of factors of 28. So first, we prime factorize 28. So I'm going to create a factor tree here. And the prime factorization of 28 is 2 squared times 7. If you need a review on prime factorization, go check out my GCF and LCM videos where I also explain prime factorization. And then we've done step 1. Now we're going to do step 2. So increase each exponent in the prime factorization by 1, right? So what this means here, you'll notice that the exponent on the prime factor 2 is 2, right? And the exponent on the prime factor 7 is essentially 1, because 7 to the power of 1 is 7, right? So now you want to take this 2 and this 1, and you want to increase those by 1, right? So 2 plus 1, that gives you 3. 1 plus 1, that gives you 2. And we're only looking at the exponents here, okay? So once we have that, we're going to multiply these numbers together as step 3. So that's going to be 3 times 2, which is 6. So the total number of positive integral factors, or in other words, the factors that are integers and positive of 28, is 6. And you can easily verify this, right? So I'm going to list out the factors just to check my work. So the factors of 28 are going to be 1, right? 1, 2, 4, 7, let's see, 14, and 28. And when you count all of those up, you see that you do indeed have 6 factors. Okay, now I'm going to move on to this other example, which is finding the number of positive integral factors of 72, right? So first, we're going to prime factorize 72. And I'm going to circle all the prime factors just for the sake so that you can see them. So the prime factorization is going to be 2 cubed times 3 squared, right? And I'm actually going to keep this consistent and change all of these to times symbols so that you guys don't get confused. So that's a prime factorization, right? We did step 1. Now we're going to do step 2, increase each exponent by 1, right? So the exponent here is 3. The exponent here is 2, right? So we're going to increase each of these by 1. So here we get 3 plus 1 is 4. Here we get 2 plus 1 is 3. Now we're going to do step 3 and do multiply 4 times 3 to get 12. And I'm going to leave this as an exercise for the viewer to list out the factors of 72 and verify that this answer is indeed correct. Right, so this is basically the process. It works with any number. And now I'm going to show you why this works, right? Why this works. So I'm going to start with the number 28. So you can see how this works, right? So you have this prime factorization here, 2 squared times 7 to the power of 1. So when you're creating a factor, what you're basically doing is you're selecting some numbers from some pool of 2 to the 0, 2 to the 1, or 2 to the 2, and you can select 7 to the 0 or 7 to the 1. So basically, I could sort of make this like sort of separate these here. So on the left side, you basically have all the powers of 2 from 0 all the way to your number here, right? And then on the right side, you basically have all the powers of 7 from 0 all the way to 7 to the power of 1. And what you're doing when you create a factor is you're basically selecting right? How many ways can you select one number from each of the left side and the right side, right? So for example, if you select 2 to the power of 0 and 7 to the power of 1, when you multiply these two, you get 7, right? If you select 2 to the power of 1 times 7 to the power of 1, you multiply them, you get 14. If you select 2 to the power of 0, 7 to the power of 0, this looks, yeah. Then you get 1, right? Because 2 to the power of 0 is 1, 7 to the power of 0 is 1, 1 times 1 is 1. And so this is how this works, right? You're essentially selecting the numbers from the powers up until you get the power of whatever is here, right? And then so let's see. So how many numbers are here? How many numbers are here, right? This is just 3 numbers. How many numbers are here? This is 2 numbers. So notice that 3 is 2 plus 1. 2 plus 1 here. 2 is 1 plus 1, right? So this is why it basically works, and this logic can be used for any number n, and this is why this trick, or rather method, works for any number n. So thank you so much for watching. I hope you learned something new, and please stick around for more. Bye!